Hello, everyone, and thanks for joining this session. My name is Paloma, and today I want to share with you the idea that Altair has regarding IoT and how to power the transformation towards digitalization on different projects. Before starting, some things about me. I studied industrial engineer here in Madrid, and in the same university, in Universidad Pontificia de Comillas, I did my master's degree. And during the last year of my master's degree, I started to work in an internship in Altair IoT department. And once I finished it, I started my full-time job as a product specialist. And right now I'm working as senior product specialist. So basically, my daily routine in Altair involves managing the deployment and the development of all the IoT platform, talking with clients, understand their needs, and all these different activities regarding clients and business. So for those of you that haven't heard before about Altair, we are a company that was founded in 1985 and is headquartered in Troy, in Michigan. We are started as a provider of software and services regarding the automotive sector. But during the last years, we've been increasing a lot. We've been expanding to new sectors. And right now we are more than 3,000 employees in Altair. We have 87 offices in different countries, and we are able to provide services to customers globally. So to understand a little bit what is that Altair has to offer to the companies, our main goal is to leverage computational science to drive intelligent decisions for a more connected, safe, and sustainable world. And I think that these three concepts are something fundamental in our daily lives. So that's why we want to help the different companies empower all these decisions regarding digitalization. So what are the tools that Altair offers to achieve all these use cases? Well, first of all, we have a wide range of tools focused on modeling, visualization, and simulation. And we are regularly updating all these to the market. And we also have some other tools more focused on modeling, visualization, analysis, and so on. So it is true that all these tools are really helpful and really powerful for many sectors. But during last years, there has appeared a new trend, which is called the digital thread or the digitalization. And basically what this means is that companies have started to understand that they need to provide insight between the different teams in the company. Because whenever a company is able to share all the information and all the data that they have between the different stakeholders, the communication, the decisions, and everything, is way easier. So if the different departments are able to know the statistics of the last product that they have launched, and if they are able to share the data that they have become from the validation test and so on, all these will improve of the product that they are selling throughout all the different phases of the product lifetime. So to be able to have all this information, management and so on, the only thing that they need to do is to be able to connect the different departments. So that way, even before launching the product, they already know what type of features they need to improve, the insights that they are going to get from the customers, and everything and all the decisions will be taken better and more efficiently. So it is true that this digitalization can be found on our daily life. We right now have smartwatches, we have intelligent refrigerators that allow us to order food whenever we run out of them. And we also have, for example, the ability to control the lighting system in our house from a simple mobile application. But not only on these small devices is where we can find this digitalization and these connected things. In the industry, we also have examples of all this. The machines are now able to measure the quality and different KPIs. They have implemented predictive maintenance models so that they can improve their lifetime and so on. And all this data and all this monitoring and controlling the data from fleet equipment will help the companies to improve their use cases. So it's true that the idea of the IoT has been in existence for a long time, but during last years, this trend has become more powerful, and our customers are starting to feel the effects of one of the global mega trends, which is the global evolution towards a smart connected everything. And this is a reality right now. We see that there are tons and tons of sensors connected worldwide. McKinsey has estimated the potential economic value of the IoT to grow from 1.6 trillion to over 15 trillions in 2 years. And that's why basically nearly 80% of organizations are planning to invest into at least one IoT project in the last 2 years. But having said all that, it is true that the IoT projects have a huge failure rate. And this has nothing to do with the technology itself, but with the ability to be able to implement this technology. So here is where Altair is implementing this IoT platform to help their customers to improve their use cases and to be able to apply this IoT technology, even if they don't have a wide knowledge on this field. So just to put different examples so that we all understand where we can see IoT. If we take a look at this picture, we will see that the products itself, they are the same, cars are the same, the machines in the factories are the same, buildings are the same, but what we are seeing today is that they are able to offer us a more deeper experience. So for example, when we talk about cars, right now what they are offering us is the full experience of having insights about our driving behavior, the environment, how the car is working, if the health status of the car is correct or not, but also in the buildings. We have at home different applications so that we can control our coffee maker, the lighting system, the air conditioning, and schedule everything. And we are connected to many devices at home. And this is just bringing the user a better experience and improving their daily life. And also when it comes to the energy sector, for example, they are able to implement new tools so that they don't have to be on site. They can control the wind turbines, they can improve the support, they can extend the lifetime just by being able to install some sensors to the current wind turbines and extract data and use that data to plan efficient decisions. So with all this in mind, Altair find out that there was a need for these new tools towards digitalization, being able to offer the users the ability to develop what is called digital twins. So it is true that there are different definitions regarding digital twins, but for us, the idea is basically that any company with any product is able to build a digital representation of the current asset that they have. So that way, instead of having to do all the testing and all the improvements on a real device, they are able to do that on the virtual representation. So that way, they are able to save costs, improve the efficiency, improve security, and many other advantages. So to cover all this digital transformation, what we have to offer are different tools. First one will be the ability to use any simulation tool of the ones that we've seen before, but also to be able to combine this with data analytics and with IoT. So that way, all the data that you're getting from the simulation phase, you are able to combine that with the data analytics, and you can keep on using this data and combine it with real-time data throughout the whole product lifetime. So our idea basically is to be able to offer the user what we call the Altair Digital Platform in the sense of being able to join the different tools as needed. So for example, if one customer, they just need to use some simulation and join that with that connectivity, then they will be able to join all these tools from Altair in order to achieve this use case successfully. If they just need data analytics and a little bit of IoT, the same. They don't need to have like the complete solution, but they can have the building blocks that adapt to their use case. So the first typical use case that we are able to achieve with an IoT platform is the following one, which is to be able to monitor any device or any asset. So the first thing that an IoT platform will allow you to is to connect with your device, but not only to be able to connect with your device, but also to interact with them. So it will be like bidirectional communication. So once you are able to communicate with your device, you can start to store all the data that the device is able to send to the platform. And it is true that sometimes the devices, they tend to send a lot of information. So one of the advantages of having an IoT platform is that you can start from the beginning to filter this data, transform it, aggregate. And once you have all this data clean and ready to use, you can implement any type of business logic that is needed for your use case. So that could be simple alerts, notifications by email, by SMS, being able to determine some actions based on the parameters that you are retrieving. And then if you want to go a step forward and you have machine learning models developed or custom algorithms, you can also include all that into the IoT platform. So that way, at the same time as you are gathering all this data on real time from your devices, you can also execute all these models and all this logic to get the results and the predictions on real time. And then the final result of all this will be a dashboard. And the good thing about them is that will allow you to control remotely your devices, measure the different KPIs, do simple visualizations and analytics, because that's the best way to understand if everything is behaving as expected or not. And also from the dashboard, you are able to interact with the device. So to understand this workflow better, I would like to share one of our use case, which at the beginning might seem like a not really digitalization project, because nuclear power plants tend to seem a little bit complex. But the reality was that for them, discover that they can implement IoT was something really useful, because they already have been gathering data for years and years, and they even have developed these complex algorithms, but they weren't able to find a way to join all this and to really get insights from that on real time. So thanks to the IoT, they were able to connect the data they were gathering from the nuclear power plants, but also join that with other streams of information. So for example, with the actual weather conditions, and all this data, run them through the algorithms that they have developed, and get at the end the result of the conclusions and the predictions of these algorithms on real time. So for them, it was really powerful to be able to have a dashboard that they can access it remotely without having to be in the nuclear power plant, but also to be able to predict if something was going to help before it already happened. So yeah, for them, one of the biggest achievements was to be able to see a real potential of these integrity models, thanks to combining it with the IoT. And then another typical use case that we can also face with an IoT platform and with Altair IoT platform is implementing edge computing. So edge computing is something that is also now like a trending thing. But what it means basically is to be able to have some things at the edge instead of having everything in the cloud. So that way, for example, when you have to run really heavy machine learning models, you can do that at the edge. So the latency of the communications will be lighter. And also, if, for example, your devices, they are sending a lot of information, and you need just to be notified whenever a specific parameter changes, all that logic, you can do that at the edge and just send into the IoT platform the real meaningful information. And also another important use case for edge computing is whenever you have, for example, in industrial environments, these machines that they are quite old and they speak communication protocols that are not really standards, thanks to the edge computing, you are able to deploy some software into these machines and to understand and be able to extract the data on a way that an actual IoT platform understands. So this will be the typical workflow that are following many companies that are seeking Industry 4.0 goals. So basically for them, what they want to have is, okay, I have my big factory, I have 10 different machines with different protocols. So I want to send all that information to the edge device, filter it, pre-process it, and then send just the meaningful information to the IoT platform. So that way I can start doing all the alerting and notification system and so on inside the IoT platform, implement my business logic, and then for sure have a nice dashboard so that I can control everything, see some statistics, and so on. And then another quite interesting use case that I would like to share is Vortex Bladeless. They are a startup company that developed these wind turbines without blades. So the journey with them is quite nice to explain, because they first start to work with us from the beginning, from when they were designing these prototypes, all the optimization of the structure, all the analysis of how the wind was affecting the power generation and so on. And once they have the prototype ready, they find out about our IoT tools, and they decided that they want to implement these simple devices so that they can connect that to the IoT platform and start sending data about the wind, the power generation, or any alert that they have into the systems. So that way, instead of having to be in the middle of nowhere near the wind turbine to be able to retrieve the data, they could do that remotely. And then right now, thanks to all the data that they've been gathering with IoT, they are starting to develop these data analytics models to do predictive maintenance, and in the end, extend the lifetime of the Vortex Bladeless. And then another interesting use case that we can also achieve with IoT, and maybe something that is not quite famous right now, but that brings a lot of potential, is what we call the virtual sensors. So basically, the idea of the virtual sensors is to be able to have a reliable data set without the need of including new hardware to your ecosystem. So for example, what we have over here are two scooters. One would be the virtual representation, as always, and the other one is the physical one. So what we've been doing with the virtual representation is train a model in order to be able to determine the weight of the person that is running the scooter. Not because we want to know the weight of that person, but because we want to know if there's just one person riding the scooter, or if it's more than one person, because you know that's forbidden. So we were thinking, okay, instead of adding an extra sensor to our scooter, let's use the hardware that we have, where we are sending all the information of the different sensors for the battery and the motor and the wheels of the scooter, and train a model and deploy that onto the scooter. So that way we can know the weight without having to install an actual sensor. And this might seem like a simple idea, but imagine if we were a scooter company, this will save a lot of costs for us, because instead of having to buy an extra sensor for all of our scooters, we can implement the same model in the hardware that we were already using in these scooters to retrieve the data, and have this new source of data thanks to this virtual sensory. So big thanks to the Global Digital Week for the invitation of this workshop. Hope you like this session, and stay tuned.